Hi, welcome to my video on graphing quadratic inequalities, part 1. Graphing quadratic inequalities, I'm going to follow the steps. Plot the vertex, plot the y-intercept. If greater than equal to or less than equal to, the boundary lines of the parabola is solid. If greater than or less than, the boundary line is broken or dotted. And the fourth step is find a point, substitute into inequality. If true, shade that region. If false, shade the other region. And let's do some examples. Y is greater than x minus 2 all squared minus 1. The vertex of the parabola is opposite of negative 2 is 2 and negative 1. We want to get the y-intercept, so we let x equal 0. And if x is equal to 0, 0 minus 2 is negative 2, squared is 4, 4 minus 1 is 3. So let's plot the vertex and the y-intercept. So the vertex is x is 2, y is negative 1. So negative x is 2, y is negative 1, which is right there. That's the negative 1. And the y-intercept is x is 0, y is 3. So we went 2 units to the right and got 3. So let's go, 2 units to the left and got 3. Let's go 2 units to the right and we'll get a 3 because it's symmetrical. Now, greater than is the boundary line or the parabola is broken. So we'll put a dotted line to indicate that the parabola is broken. The boundary line is not included. And now we have the shade. It says greater. And greater, well, two ways. If the parabola goes up or down, greater is always the upward. So greater would be all the points that's inside of this parabola. Another way to do it is take the point 0, 0. Take this point right here, 0, 0. Notice the 0, 0 is not in where I shaded. So let's check. 0, 0. Let's put 0 and 0 in this. So 0 is greater than 0 minus 2 squared minus 1. 0 is greater than negative 2 squared is 4 minus 1. 0 is greater than 3. No. So where this dot is, we don't shade. So there's only two regions to shade. Either shade outside of here, all this, or inside in here. Since 0, 0 didn't make it true, that means I shade in here. But because the parabola is going this way, greater is always up. So less would be down here. Keep that in mind either way. Now this is the same parabola, which is vertex is 2, negative 1. And so, but this time the parabola is greater than equal to. Because it's equal to, we make the boundary line solid. It's a solid boundary line. So there's a solid boundary line. And greater than is going up. And again, if you try the point 0, 0, and it says no, then we shade in here. But if you pick this point right here, if you pick the point 1, 1, if you plugged 1, 1 into the equation, let's see, 1 greater than 1 minus 2, 1 greater than, and that's negative 1 squared is 4. 2, 1. The point is 2, 1. X is 2, y is 1. X is 2, y is 1. So that's a 0. So 1 is greater than or equal to negative 1. And that's true. So because that point, 2, 1, makes it true, that's a 2 and a 1 because it made it true. That means I shade in this part. Remember, you either shade inside here or you shade outside here. And again, this is the same parabola, -1, 2, -1, y-intercept, and this is less than, and there's no equal sign, so the boundary line is broken, like this. There's the broken boundary line. And less than, make this a little loop here, less than is below, but again, if you check the point 0, 0 with this one, check 0, 0. So the point that I'm checking is 0, 0. So 0 less than 0 minus 2 squared plus 1, 0 less than, and that's -2 squared is 4 plus 1, 0 less than 5. That's true. So the point 0, 0 is in the graph, so that's why I'm shading here. So that means all the points that's here. So this parabola can keep going up and up and up. So these points, all these points make this inequality true. And again, all these points inside of here make this inequality true. And D, same parabola. Again, that's a -1, so it's 2, -1. Y-intercept is 3. Notice it's less than equal to. Because it's equal to, the boundary line is solid. And less than, there's the parabola, less than is below, down here. So notice this one, there was no boundary line was broken, but still below. This boundary line is solid, shading below. Again, the point 0, 0 would make this inequality true. So if we take the point 0, 0 and plug it in, you'll get 0 less than or equal to. Put a 0 in here, and I'll get a 4 plus 1, 0 less than or equal to 5, true. So this point 0, 0 makes it true, so that's why we're shading here. E, we have a vertex on this parabola. The vertex is opposite of +1 is a -1, comma 2. We're going to let x equals 0 to get the y-intercept. So the y will become, put a 0 in, I get a 0 is a 1, 1 squared is 1, that's a -1 plus 2 is 1. So that's 0, 1 as the y-intercept. So the vertex is -1, 2, right there. And the y-intercept, x is 0, y is 1, right here. So 1 to the right, we go 1 to the left. So let's check. The boundary line, there's no equal sign, so the boundary line is broken. There's the broken boundary line. And notice the parabola is going down. So greater than is above. So that means we shade up here. If it was less than, we'd be shading inside. But again, notice, let's check the point. Now, we want to make sure. If we're not sure if the point 0, 0, where it is, probably what we could do is check this point right here. Check the point. We're going to check the point 3, 0. So y is 0. We're going to check the point 3, 0. So y is 0 greater than negative. X is 3 plus 1. 0 is greater than. And that's 4 squared, 16, -16 plus 2. 0 is greater than -14. That's true. And that means this point is in the graph. So the shading, so this point is here. So we'll shade. There it is. Notice the boundary line is broken. The points on the parabola do not satisfy this inequality because there's no equal sign. We have the same parabola here, and the vertex it's the same vertex, -1, 2, and I got a same y-intercept, but this time this one is greater than equal to. Equal to means it's solid. So it's solid. So I'm going to make it solid. Same shape, identical to the other one. Only it's solid. It's an equal sign, solid because of the equal sign, and we're still shading because greater than. Again, how do I know? Well, check with the point. Check the point. Take any point outside of here, or take this point. You could take the point -2, 0 and plug it in. -2, 0 would make it false, whereas -4, 0 would make it true. Okay, so we have a couple more, let's say, examples, but let's not use them as examples, but let's use them as practice. Here we go. Now, let's get the vertex. The vertex is the opposite of -2, which is 2, -3. And we're going to let x equal 0, so y. And we just pretend that it's an equal sign because we just want the y-intercept. So that's a 4 minus 3 is 1. So that's x is 0, y is 1. So the vertex is 2, -3, 2, -3, which is right here. The y-intercept, x is 0, y is 1, which is right here. And greater than equal to. Equal to means the boundary line is solid. So if we go 2 left and get 1, if we go 2 right, we should also get 1. So the boundary line is solid. And greater than is above. But let's check, what point do we want to check? Let's check this point right here. This point is 2, 0. So let's take the point 2, 0 and plug it in. 2, 0 in this inequality. 0 greater than equal to 2 minus 2 squared minus 3. 0 is greater than, that's 0 squared 0. So 0 minus 3 is -3. 0 is greater than true. So this point is true. So that means we're shading here. All points. So remember, this parabola goes up and up and up. So these points are in here. Any point that inside of here makes this inequality true. And B, again, let's get the vertex. The vertex is opposite of +1 minus 1 and a 2. And we let x equal 0. So we get y is x is 0. So we get, that's 1 squared is 1, so -1 plus 2. So y becomes 1. So we get a 0, 1. So just to make sure, vertex is -1, 2, and we plug x is 0 in. Looks good. So we got vertex is x is -1, y is 2. X is -1, y is 2, right there. The y-intercept is x is 0, y is 1, which is there. So 1 unit to the right gives me a 1. 1 unit to the left should give me a 1. So this parabola is going down, but this one is no equal sign. So the boundary line is broken because the parabola, the boundary line is not a part of the inequality because there's no equal sign. So it's broken. And less than, well, less than is below. So the only way to go below is in here. But let's check this point. Let's check this point. What's this point? This point is -1. I could check the point 2, 0. I could check the point 0, 3. I could check the point 0, negative 1. Pick any point, but I picked this one. So y is 0, x is negative 1. 0 less than, and that's a 0 squared 0, so that's a 0 plus 2. 0 is less than 2, true. So this point makes the inequality true, so that means I shade in here where this point is. And that means all the points that's over here. All these points outside of here. Remember, the parabola keeps going down, down, down. So these points will not make it true. This goes down, down, down. These points will not make it true. These points inside of here will make the inequality true. And that's how I do it. I pick up vertex, y-intercept, and graph it with a boundary line, broken or solid. And that's graphing a parabola. And if you like my video, click the like button, subscribe button, the notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel. Thank you very much for viewing my video. Bye-bye.